And with that, let's move into today's program. Our first speaker was quite involved in the early days of the alt.net movement, which was the thing that happened in the relative youth of the .NET framework, with people that were striving to sort of break free of the proprietary Microsoft silo and incorporate other tools from the open source community in their software delivery. He has been writing a couple of books on subjects as disparate as unit testing and leadership. And with well over 20 years in the industry, as a teacher, as a developer, he comes packed with experience to share. Please welcome to the stage, Roy Osherove.
Thank you, sir. Thank you. Okay, so how do you follow that? I really need a defibrillator. So yes, 2 years, almost 3 years. It's pretty crazy. It's really fun to see faces and people again, not Zoom screens. I'm really happy to be here. This talk is completely new. I've never done it before. In fact, a lot of things that I've been doing in the past few years are really, really new. And I thought that I would share some of my experiences working in this new and interesting world. Specifically because a lot of people are either very afraid of it, don't know it, or afraid to try it. Well, I'm here to give you an example of what it's like to work in this world. We're going to talk beyond the hype, beyond the scams. We're going to talk about technology and why I like it. Actually, while we're doing this, I'm going to give you some background music. If you don't know, I have an alter ego. Let's see if that works. Okay. This is something that I wrote. Okay? And this will be our background for the beginning of the talk. You see, I've been a developer for 20-something years. I've worked in a lot of different fields, a lot of different positions. And that's cool. You know, as a developer, you go through, you learn different things, you come across different issues, and you find your way around them. And at some point, I started writing books about it, and I started doing training about it. It was a lot of fun. But every few years, I find myself kind of reinventing myself and looking for the next new thing, an interesting thing. Okay, that's kind of where it really gets interesting. So, in about 2012, I got introduced into the world of crypto and Bitcoin. At that moment, it was mostly for the currency side of it, and I was kind of really, really excited to learn about it, and I really liked the technology behind it. But a few years later, Ethereum and smart contracts came in, and I looked at it, and it felt completely weird. It looked like a really, really simple programming language, and it had no value. I really didn't understand it, so I kind of dismissed it. Kind of looked like Visual Basic in my early days. But what I already started saying is that you already know that sometimes in conferences I used to do like guitar, and I used to play songs sometimes. And that's because music is a huge part of my life. For the past 10 years, my midlife crisis was trying to be a trailer music composer. So this is my alter ego. It's called Osherove, etc. And the reason that I wanted to create this, I wanted to see if I could make money just out of music. Okay? So this is the type of music I wanted to create. And it's kind of this big, bombastic music that we want to, hear in trailers. So my dream was to create music for Marvel trailers, as an example. And I know it kind of sounds silly, but that's the thing that I was kind of working towards in parallel. Could you reinvent yourself as a composer? But during that time, I got introduced into the music world and really understood what the music world was about. And when I say music world, I mean the professional music world, the world where you're trying to make money, the music industry, etc. And that world is really, really complicated, and it's really, really monopolistic, and there are many, many problems with that world. So I wanted to find for a few years, I wanted to find a project that fits me, that's something that is interesting to me, that connects all of these dots together. What can you build that combines the world of music, that combines the world of technology, combines the world of smart contracts, etc.? Is there any type of killer application that you can build using those things together? And I came up with this project, and it's now a company called Legato, which basically allows you to sell music and monetize it directly to other people without going through lawyers or through banks. It's a startup. I'm reinventing myself as a startup founder. And I always tell people when I teach is that you have to be in a place where you feel completely uncomfortable. Well, let me tell you, 20 years in the software business means 0 when you're trying to create your own company. All of the skills that I learned were about creating software and getting people to create software. Creating a company, getting funding, and trying to get all this stuff working together, feel like a complete idiot. So I'm really, really happy that I feel really, really uncomfortable right now. And so I'm going to talk about the journey and why I chose to create a company in this space, but I'm going to talk about it from the technology standpoint, how I even got started, and hopefully you'll understand why there is this huge value in doing something that's built on the blockchain. I'm not going to talk too much about this, but the basic idea is that you can take your music, your video, and you can kind of monetize it or kind of onboard it into the world of Web3 if you've heard all of these weird terms. And what does that mean when we're monetizing stuff on Web3? What does it mean to disintermediate, to remove third parties from different transactions? So I'm going to talk about it from absolute zero. So the first thing we're going to talk about is why you should care at all. I mean, you've probably heard of these terms. Maybe you've even looked into it. But here's the way I see the industry relating to blockchains today. At the top is what everybody sees, because that's the loudest part. So you see people doing scams and hypes and speculators trying to buy and sell and trade different cryptocurrencies. In the middle, if you're not actually getting into this and trying to look into it, you will not see them. But there are a bunch of really, really useful projects, mostly to do with finance, that have already proven to help replace or give a really powerful alternative to the traditional economy in many ways. And these are not scams. These are actually really powerful projects that have proven themselves to work even during times of ups and downs. They're not speculation-related projects. They're actually technological projects. Usually they come from the world of decentralized finance. So collectively they're called DeFi. I'm less interested in DeFi or decentralized finance. I'm interested in what do you do with the music industry. So that's, to me, the really interesting stuff is below it. How does all this stuff work? Is it interesting? Is it useful? If you wanted to build something that you could never build before because it was too complicated, too difficult, or you would have too many dependencies on outside factors. So, I think you should care about this technical world if you've ever wanted to build something that is completely different from something you've ever built. And when I mean different, I mean really, really different. A lot of the ways we even think about code, writing code that runs on the blockchain, run very counterintuitive to how we are used to write code. A lot of the things that I believe in the traditional software world, some of them cannot actually exist in this world. A couple of simple examples: continuous delivery. You can't actually do continuous delivery, mostly, on blockchain-based code, because once you deploy it, it becomes read-only, basically, or immutable. You could create patterns to try to change it, but that actually creates other problems. So what do you do if you can only deploy code once? What the hell happens to your software process? And to me, that's interesting, not because it immediately is much better, but because what does it force you to think about when you're in this type of world? What happens underneath all of the hype and the scams? What does technology actually enable? And to me, the frustrating thing about technical conferences in the past few years is that people are not looking at the technology. They're looking at the usages of technology. So imagine that Postgres or MySQL, a new database was created. And then the first usage of that database was by a casino company that used that database to scam their customers. And now imagine that there's an entire industry saying, oh, Postgres is terrible. It's a scam database. It sounds terrible, sounds completely, doesn't make sense, but this is exactly what's going on with blockchain-based technology. It is a really powerful set of technologies that enable really powerful things, but they have been so far co-opted by really loud, scammy actors. And it's up to us to build something really, really useful on top of that stuff. And there have been many, many interesting attempts to try. And what's really cool is it's still relatively nascent. It's still relatively new, which means that if you get into this industry today, there is, first of all, a lot of need for technical people to join this industry. So you can make really, really good money as a developer in this industry. And if you're a security researcher, you can make even more money because security is top of the line in terms of need. Second, there are many apples lying on the floor. You know the term like low-hanging fruit? You don't actually have to pick fruit. You just pick it up off the floor in this industry right now. There are so many problems that are still unsolved, but there are many companies working on them. For example, identity, privacy. There are a lot of things that blockchains enable, and there are a lot of things that by default they don't enable. And so what does that industry look like in 10 years? Nobody really knows. But the people that are going to make it different in 10 years are working on it right now. That's kind of where I am in this. The second question to ask why would you even build something on a blockchain? Because maybe you've heard that the blockchain is the slowest database in the world. They're absolutely correct. Which means by default you shouldn't actually build on the blockchain. The first excuse to build something on the blockchain should be when you want to let go of control. Okay? If you're trying to build something where you actually let go of control of the something that you built, that is one of the best use cases to build something that runs on a blockchain, because it is a decentralized database that allows the people or the wallets that use it to have complete control based on the code that you write. And so it is designed to be secure by default in the public blockchains that we mostly know, and it is designed to be transparent, and we can use it to create something that, if we try to create it in a closed way, we would kind of suffer the old ways of what happens when we build closed software. So what's an example of closed software where we can actually hurt ourselves by building it and gain control? Maybe you've heard of FTX. You've heard of FTX, the collapse of this huge exchange where people lost a lot of money. It does exist in the crypto world, but this is an example of closed software that claimed to use crypto-based software, but it was not actually open. It was actually closed, and it was fully controlled by specific entities. And one of the claims that we can say is, if you're building something and you have an inherent incentive to control it, maybe today you're going to do right by your users, but tomorrow you can choose, or even if without your choice, you can be bought out, and then your users are basically, anyone can do with their data anything they want. So if somebody uses your platform, you can take their information, you can hide it from them, etc., which is the opposite of giving up control. But could you create a system where if you build it, even if your company shuts down tomorrow, the system will continue working? Even if your domain doesn't work anymore, you can actually build a website that still uses that system. Can you build a system where every version of that system, the users choose which version of that system to use, and you cannot control what they choose? What would that system look like? And that to me is a very powerful idea, because there are some things that when we're trying to change them, a closed, controlled system is not good enough. For example, the music industry. Because the music industry is completely defined by hiding information and making money off of different databases. So all of the players, the big actors in the music industry today, the way they make money is by hiding information and controlling it. And there have actually been attempts to try to change the music industry to be more open. But nobody has an incentive to open this information. Did you know there isn't a single song registry database in the world today? If you wanted to register your song, each country has its own multiple databases. If you want to get royalties for your songs today, you have to register in dozens of places to get money from different places and different usages, and each one has its own database. And some of them are different, some of them are actually just Excel files. And so it could take you between 6 months and a year and a half to get your money after your song plays somewhere on TV or radio, etc. And on the way, 60 to 70% of it gets lost to all of the players in the middle. That's the music industry for most of the musicians you'll ever ask that try to make money out of it. And it's designed that way because there's all this centralization that goes on. But if you could reimagine that as an open public registry where you have this public transparency of things, a lot of the things that are happening today will stop happening, which is exactly why the music industry has not changed and has not adopted blockchain-based stuff, because it gives up control. So rule number one, if you're going to build on a blockchain, make sure that the thing you're building, you're okay with giving up control in some way. And if you're not giving up control, then you will be at the same pressures of the old web, which is at time of stress, time of need, we can shut down the infrastructure. And so we're back to square one. Second, to build on a blockchain, a good reason is if you want security, for example, auditing, you want transparency, and you want to have logic plus programmable money built in. So if in a traditional industry, you would use banks, and you would need, as a startup, you would need to get permission from multiple banks to save money for your users. If you're building on a blockchain, you could use the blockchain-based currencies inside to actually transfer payments between different smart contracts. And a lot of these currencies are actually stable coins, which means that they'll actually have a dollar value that you can actually use, which means that you can disintermediate and actually work without banks most of the way for your users. The only time they're going to need to work with banks is if they ever need to take the money out into a bank. But the more use cases there are for using such currency, the more users can just keep their money inside, on the chain. That transparency is very important because then it means I don't have to trust you if you're building something. I can see exactly how much money you got, how much money I got, and I can even see the code of the program, which is what we call a smart contract, and exactly the logic that it uses. And finally, we can use all these things together to increase efficiency of something that today we have to trust other people to do. So imagine signing a contract and paying something. Imagine buying a house, just as an example. What do you do when you buy a house? Well, you take a bunch of money and you usually put it in the lawyer's hands somewhere, and the lawyer makes sure that the money is actually all received, and then they provide you with a double-sided signed contract. So the lawyer is responsible for making the transaction happen so that both sides are protected. But if you could create a piece of code that does exactly that thing, where it can automatically enforce payment and automatically create that type of new license or that type of contract and get it signed in a way that is fully verifiable, you can get rid of a lot of these trusted third parties that today have to do things manually. You could create logic in your own closed source application that does exactly the same thing. I agree. But then people would have to trust you that you're actually doing the right thing, and you would have an incentive to maybe sometimes not do the right thing. So by actually putting something away from us and letting a smart contract make some of the decisions, we can actually make users trust us more because we don't actually control the logic as well. The logic is visible to everybody. If you could see the logic that the bank has for calculating a mortgage, you could see the code that the bank runs, you would know exactly what to expect at every point. That's kind of what we're talking about here. If you wanted to know if this industry, if this kind of infrastructure is being used today, this is just one vertical on the blockchain today from April 2022. So today it's actually much bigger. These are just projects being built on the blockchain relating to the music industry. Okay? But there are many other types of projects for other types of verticals. And what you can see here that some people are creating new types of decentralized labels where artists are working together and actually sharing revenue using smart contracts, where artists are actually tokenizing some of their music, and instead of just licensing it to Spotify, they're also creating collectibles from it and allowing people, their fans, to collect it. Imagine a signed photo of Pink Floyd while they're recording their first album. That's what this kind of a memory, but it allows them to fund music that's going to happen tomorrow. There's all these kind of weird, interesting, alternative experiments, right? Maybe in a year or two, half of these will not exist. But there's going to be a new set of projects that are existing today that will exist tomorrow. What I'm trying to say is that there is a huge industry of people trying to see what happens if you do X, what happens if you do Y. And some of it is really, really innovative because it's using all these new types of mechanisms. And that brings us to this world of Web3. If you've heard of Web3, let me explain what Web3 is supposed to mean. Web 1, when people talk about Web 3, they talk about the fact that there was Web 1. Web 1 was kind of this read-only web, America Online and stuff like that. You would go, you would see a website, but you would not have control, and you could not create your own content usually. There was this controlled by these huge conglomerates, but it was mostly read-only. CompuServe, America Online, etc. Today, we can create content. Twitter, Facebook, MySpace used to be, and all that stuff. So we can create content, but we have no control of the content that we usually create. So when we create content, it is controlled by the companies that host the service. So we're basically giving away a lot of our creations, and we're giving companies permission to use them immediately for the hopes of discoverability, etc. But we don't actually have control over the creations that we create, that we make, mostly. Web 3 is about read, write, and own, which means that not only can you create stuff, you can declare ownership of that stuff in a way that is programmable. So you can declare that you own a specific piece of something, and if we have a set of decentralized systems that support this type of declaration, we can build on top of it. And I'll give you some examples in a second, but the promise of what Web3, which is basically a redefinition of a blockchain-based smart contracts. But the promise of what Web3 is, we do not want third parties in our business. We want, if I want to sell my music, I don't want to have to go through a label. I want to sell directly to you. And I want to get the money directly. But it was really difficult to do that before. Or there was a lot of third parties before if I wanted to do it, and now I can get rid of 90% of them and just work directly, peer-to-peer monetization and ownership and collections and direct fan engagement with other people. So there is this promise, and a lot of projects are trying to achieve this promise. Some of them are more successful than others, and I'm not here because it's already very successful. I'm here because there is this movement that's happening, and it's really interesting, and I don't know what we can still build on it. That's why I'm building on it, because I'm trying it. So you have decentralization, you have permissionless, you have native payments, you have trustlessness, which means that if you can see the code, and the code cannot be changed, then you know what's going to happen when the code runs, and you can put something in, you know what the output will be. Most of the time, if the code is simple enough. And if the code has a bug, you're also screwed, which is one of our problems today. So some use cases, some people are using blockchains today to create new types of currency. So if you've heard of tokens, right? We'll see what a token actually looks like as a smart contract. But anything that happens on a blockchain runs through what we would call a smart contract if we're talking about stuff like Ethereum, etc. So you can use it for currency, but currency is like the notepad of usages, okay? So currencies and NFTs are like the simplest types of usages that you can build. But if you could build any type of program, which is Turing complete, you could build a lot of interesting logic. So escrow contracts so that can replace banks, royalty payments that can replace centralized authorities that distribute payments. If I wrote a song with 5 other people, who do I need to trust to pay all those 5 other people? Today I would need to trust a label or someone to make sure that that stuff happens. But I could build a payment system that distributes the money because we have programmable payment systems. So you can build your own PayPal if you really wanted to. And there are still not many killer applications except for decentralized finance yet. So I'm just gonna just verifying that we have like these 2 main types of blockchains today. If you're deciding what blockchain to build on, you have to realize that there are 2 main types of blockchains the way I categorize it. The ones with smart contracts and the ones without. Okay? Bitcoin is an example of a blockchain, the OG, that proved and still proves that you can build something that has real value in terms of usages and utility of moving things around without censorship, without government intervention, but it does not support smart contracts, so it has limited utility. And then you have stuff like, for example, Ethereum and other blockchains that support this extra level on top of what the blockchain already presents, and they support this programmability layer, which we call smart contracts, but it's a terrible name for it. If we had to rename it, I would probably call it blockchain smart code or something like that, or stupid blockchain code. Maybe that's a better definition. Because you can build, imagine Lambda functions running on a blockchain. That's how you should think about smart contracts, okay? But also you get storage built in. What can you do with that stuff in a way that cannot be that can be fraud proof? And the smart contract is where, to me, the most interest is. So if I had to describe what a smart contract allows you to do, imagine this decentralized, this distributed Excel file. And this Excel file, everyone in the world can see the same Excel file. And when you're creating a smart contract, what you're creating is you're creating a new tab in that Excel file. And you can declare what fields you have and what values in each row you insert. And you can even put logic inside that Excel file. For example, that you can never remove a row once you've added it. You can never change it. So it's only forward-looking. And you don't have to worry about the fact that it's forward-looking. You have built-in security. The blockchain will prevent anyone from changing it. So you don't have to worry about that security aspect. And second, you can create formulas that calculate things and actually change values, but each value change is just a new row. So you can see the entire history of all the changes of everything on that file. Anyone can create a new tab and new formulas. It's permissionless. So you can create a new type of smart contract that has new types of logic. Formulas can also manipulate money. So you can even charge people money to change or to add new rows to your special tab. We'll see why that might be important. And it costs money to deploy a new tab and to change. So it costs a little bit to change, to do every change. And that helps to prevent a lot of unnecessary noise in the system, because it costs a lot to create noise in the system. That's like my basic kind of, in my head, when I view something, that's how I view it. Which means that if we're talking about a currency running on Ethereum, a currency is really just another tab in an Excel file with a list of information of who owns what, how many of that currency. That's basically, imagine that. So when you're sending something, you're just triggering a function that says, the balance of this person is now 1 less, and the balance of this person is now 1 more. And you're just changing this small tab, this small sheet. That's the entire thing when we're talking about what these tokens are. You're not actually moving anything around. You're just going to this public whiteboard, and you're like, I hereby declare, and I'm proving it with my own private key, that I'm moving something that I fully control, and I'm changing the balance for myself and for that other person, because I'm allowed to do it. And there's logic that allows you, or doesn't allow you, to do that stuff. That's the entire thing when we're talking about how that looks. This is a very simplistic example of actually a smart contract that we can actually deploy and run. And this is where things become really, really interesting. Because when we're looking at this, it kind of looks like a class almost in C#, right? So we have this variable called count, and we have a couple of functions like get and increment and decrement. Now, I'm not saying this is amazing code. I'm just, what is the minimum amount we have to see to understand how it works? So the first big difference we have to understand when we look at code like this is that on line 8, this variable is not actually a variable. This is actually storage that is saved on chain, which means that whenever you change it, you're not changing anything in memory. You're literally going to the blockchain and changing the value of that. So you can see the history of all the changes that happened to this value, and you can query it, and you can see it. So there is no, usually the output of any variable that you save like this is immediately as storage. That's really important, because storage on chain is how we basically save information on chain. That's how we basically do everything. So if I wanted to prove that you're allowed to do something, I have to save it somewhere. I have to say this person is allowed to do something. I have to put it in like any type of, maybe a type of array or anything like that. So by default, you don't actually have in-memory variables. You could create ones inside functions, etc. If you're declaring it like this, you're basically declaring a storage. And storage, when you're trying to change it, it costs what we would call a small amount of gas. And a gas basically is just a small cost of Ethereum or whatever the blockchain you're using, so that you can't just create noise and create like these dummy transactions. To change it, you actually have to create a transaction on chain. And the way to create a transaction on chain is that you have to create a special wallet where you have the private key to, and you're basically using cryptographic means to sign a special message that allows you to run this transaction. And because only you have run this and only you have the private key, I can see exactly who did what on chain, which means that that's good and bad for some people. You have full transparency to see which accounts did something. You have built-in security in that there is no way to say that if I'm doing something that I'm saying that somebody else did it. You cannot spoof addresses. You either did it or you did not. So we get this globally available storage by default that is secure by default. That is, we can see the entire history of it without doing anything. We just get it for free. We get full transparency on the actions and history, and we get full action ordering, which means we have eventual consistency. If two people are trying to change the same value, those transactions will have to come one after the other, which means that the final result of that value will be visible to everybody, and there will be no dispute eventually what is the final result of that value. This is important because when we're trying to create something like an auditing system, etc., we really need that type. And in traditional systems, it takes a long time to create a system that has such consistency and such security. Here's another example of taking it to the next level. I could take the increment function and declare it to be payable, and I can add this kind of require function at line 15. And the require is the special instruction that runs inside the smart contract that is basically an assert. And the assert verifies message.value. Message is this special construct that whenever you run a smart contract, you have this built in a lot of information. What's my block number, who sent the transaction, and how much value, how much money they're sending inside this transaction. We can require that the only way to call an increment is that it costs some type of money. So if I'm a trusted source and I'm creating this special song registry and I'm trying to fund this registry, I can say, if you want to register your songs on my registry, it costs 0.1 Ether whenever you register a song. And this money I can later take out and use it to fund the business. So the business itself changing rows, I can actually require changes to happen. We'll see how many more things can happen because of that. So I have built-in transactionality. I can actually have programmable payment mechanisms without going to a special bank. In fact, if I have 0.1 Ether in my wallet in the time of that transaction, that money will actually transfer into the smart contract. The smart contract can actually save that money, and I can then later take it out if I'm the owner, and I can create a function to remove that money from the smart contract. Here's another example. What if we wanted to create fully transparent voting mechanisms? So imagine a voting smart contract. Now here I'm introducing two new things. At the storage level, we have two integers at the top, votes A and votes B. And I have this thing called the mapping, which is basically a hash table. And the hash table, the key is the address, and the value is a Boolean, whether that address has voted or not. And then I have a function called vote A and vote B. And of course, I could change how that works, but just to simplify. When people call vote A, I have this special required that says that address should not have voted yet. So I'm just verifying that in the hash table, the message.sender, which is guaranteed to be correct at the blockchain level. I don't have to worry about getting the right information. I can check if that's actually not true, and only then do I change that value. Okay? So I can now say voted for message sender is now equal to true, and then I increment the votes. So now I have this really, really simple piece of code. I don't need a person to verify if you voted or not. I don't need to check your ID. I just have a smart contract and a piece of storage and a piece of logic, and everyone can see this piece of logic. The same thing for votes B. And then I have this function called getWinner, right? Either A or B or equal. Now imagine that this was a really, really critical vote. So I do not want to put the power of counting the vote to any special party, because I want it to be clear that anyone can use this in a way that they don't have to trust the other person. If I show everybody the code and everybody knows exactly how this smart contract works, they would feel more comfortable using this smart contract for voting. Of course, there are many things we could add to it, etc. But on a simplistic level, if you can see the code for the smart contract and you understand what it does, you understand when it does what it does, and this is all of the code. There is no other code that runs. Okay? Then you're actually more likely to trust it and say, okay, I'm willing to use it. And one of the ethoses of Web3 and smart contracts is that almost any business today that wants to get users to use its decentralized applications open sources and shows the code of the smart contracts in a verifiable way. So before I use a system, I don't need to know who the people are that actually created the system. It would be nice, but it's not really the important part. The important part is that I can see the code that they created, and I can audit it myself, and I can see the history of all the transactions that happened on that smart contract, and I get to decide whether I want to use it or not. So I can see if there is a scam going on, I will see the code that allows the person to remove money without actually checking. I'll see if there is a way for someone to vote even if they've already voted. Okay? Now, what's something that doesn't exist here that absolutely should? Some of you already know this, but this is a really big deal. Technically, you can create as many addresses as you want. So technically, you can just create a new address and keep voting, etc. So the idea of identity is still very much a big problem. And there are many companies trying to solve the issue of identity so that when an address votes on something or uses something, you know that it belongs to a single person. How do you do KYC on the blockchain? Is it good or not? How do you attach it and you verify that a person's address is only that? And there are many ways, interesting ways around it, but this is an example of a problem that's still lying on the floor, but this is a relatively already kind of crowded market just for that specific problem. There are some really big companies trying to fix that issue. So maybe in a year or two, it's going to be a non-issue. But right now, multiple addresses are still an issue, and you have to take care of it in some way. For example, you can do KYC and then whitelist addresses, but then KYC by definition is centralized. Somebody has to verify, right? So you are introducing a point of centralization, and so you gain control of the system. which is a part of this interesting dilemma that happens in this new world. But you do have transparent trust. If you can see the code and you understand, you can see the risks. Here's another example. I'm using mapping again here, but this time I'm taking control of a special ID. Imagine a running number, okay? And this running number, let's say that I can later query this smart contract, because I can, and anyone who owns one of the numbers in this smart contract, I'm going to allow them entrance into my show. Because I can, because technically I can query a smart contract. So imagine that every ID here is basically a concert ticket. So how do you mint a concert ticket? Well, you just call this function, and immediately I'll use the message sender value, and I'm going to set it in this mapping at the top, and I'm saying ID number 3 belongs to this address. And then I can also say, I can create this function called isOwnerOf, and all I'm doing is I'm querying this storage. This is not complicated code, right? We've written code that's kind of like this, usually thousands of times. The difference is that this code actually runs on blockchain storage. But this type of simple code allows me to do something without a third party. For example, imagine that I paid for it, so now I purchased a ticket. I can query that your address owns an ID, right? How do I do that? I can create a function here. Any function that I wanted that uses the storage that gives me a Boolean, just as an example. And so I can even sell my ticket and I'll say, hey, give me $10 and I'll replace the ownership. And I'll call this function. Can anybody call replace owner? No. My smart contract is verifying that only an owner of this ID can replace the owner of that ID. So I can change the ownership of my ticket without going to a centralized office. Really, really simple code. It's not, at the end of the day, it's not complicated code. It's actually crazy how simple it is. The moment we understand that all we're doing is we're just saving stuff on this type of public ledger, this public whiteboard or Excel file, and we can add interesting conditions on when you can change it and what the results would be to calculate some stuff based on it. Right? So the big difference between just writing a regular code and this is that this is public. The entire world can see this storage. I don't have to do anything for anybody to see. I don't have to expose it. It's on the blockchain, which means any other company or contract can actually go and query this smart contract and give other benefits to people that hold my tickets. I don't even know. I can't even control it. And this is what we call composability. The fact that everyone can see everything gives you composability because you no longer have to create these integration APIs, etc. Because all I have to do is I have to query the chain and see all of the users that a specific thing has, and automatically give a new smart contract and say, hey, if you are the owner of this other smart contract, and I can literally, in a function like this, I can actually query another smart contract based on its address, and call a function on other smart contracts. Right? So we can have integration between different smart contracts if we wanted to, but it could be one way. In other words, a smart contract can call the function isOwnerOf, not a person. I mean, a person could, but also a smart contract could. Both of them could. So people can build integrations that I haven't even thought about. This composability, this Lego kind of a thing, is one of the best things about the blockchain. And that's why when you hear sometimes blockchain, you hear the words metaverse and stuff like that, and gaming. A lot of it is hype. But at the base of it, there is something that's actually pretty true. Because if you wanted to have interoperability between games, you could technically have now this shared database where if you own a specific piece of armor, then the other game can now provide you with extra benefits. So you don't have to move things between games. You can have this big shared repository, and every game can decide what they can respect in terms of what information they care about. The same thing for metaverse-based information. If you own a ticket, you can enter this room, etc. Because it's this public database, public API, that nobody can really control, then you have this type of trusted information that you can build upon. And that's pretty cool. And that's why people are like, we don't know what we can build, let's try a bunch of stuff. And if we wanted to build something like this today without blockchain, it would be really, really complicated. We would need to have a lot of partners just to get them to integrate, etc. So this type of information is also useful if you're trying to get people from your competitor, because you can see all the information on the chain of which addresses are being used, etc. And you can airdrop information, or you can allow them to get benefits just because they're already using your competitor. So the market itself is actually more competitive. Let's see. This is what a token, a currency, looks like on a blockchain. It's a mapping, mostly, yeah. It's a mapping of an address to a balance. So if you wanted to say, hey, how much of a Legato token do I have? We don't have a token, but let's say that we did. Then it would just be storage, right? And it has a name and it has a symbol, etc. So maybe you've seen this. Blockchains have thousands and I think more, hundreds of thousands of tokens today. This is how easy it is. You can create a token today in 3 minutes because it's just a piece of information in storage on chain with some logic. There's a function called transfer, for example. So if I wanted to transfer something from me to you, I'm not really transferring anything. I'm just saying, hey, this whiteboard, it used to be 0, now it's 1 for you. It used to be 2 for me, now it's 1 for me. That's all it is. So so if you wanted to know how much money you have of a currency, you actually have to query the smart contract of how much balance that person, that address has. But this is how simple. So if a currency is just a smart contract, just a bunch of functions in storage, what else can you build on smart contracts? Well, you can start building a lot of different pieces of logic. You can start building signatures, you can start building payment splits, you can start building things that I have no idea what we can build yet. But imagine, you can build anything on this decentralized storage. And you can create any function that you want. The thing that makes things scalable is when people declare standards. So what is a standard in this world of smart contracts? ERC20 is an example of a standard. It is a standard because we have declared that we have this common interface that we all want to use for a token, and it has a transfer function, for example. And it has a symbol and it has a name. This is what a standard looks like. So if I wanted everybody to know that I have a token, that I create this new token, I just have to implement these functions in the interface. So standards are a way for other applications to immediately, very easily integrate. But I don't need a standard if I know exactly how your smart contract works. I need a standard if I don't know how it works. But I know that it supports the ERC20 standard. Okay? So standards are a big deal. NFTs are an example, ERC721. NFTs are just smart contracts that have a mapping like this. And they basically have this running ID. And when you buy an NFT, you're not really buying an NFT. You're registering an ID, a running ID to your address. That's basically what they do. The only difference between what this and what most picture NFTs do is that there's also another function called, metadata URI, which is basically a function that takes an ID and gives you back a URL, a string. And so if I wanted to show a picture, that picture is usually not saved on chain. It's saved in other decentralized storages, etc. And that's a whole talk for a different time. But the images and the metadata that's related to an ID are not actually saved in the smart contract, which leads to a lot of scams as well, because it might be on a domain that some people control. And so if that domain goes away, your NFT goes away, just as an example. So if you add to your special NFT smart contract a way for you to stop people or to change the URLs of all of the IDs, you can do what we would call in the industry a rug pull and kind of destroy everyone's value at the same time. But you don't have to. That's because people decided to do it. But you can create NFTs that have licenses in them, that are fully legal, that when you use them, you're actually allowed to do something that you weren't before. For example, you can create a licensed NFT, which is kind of what I'm building. When you're minting something like this, you're actually getting rights to use one of my songs. So you don't have to go to a special lawyer, etc. You mint an NFT and it's attached to something that cannot be faked, which is an actual license with parameters, and that's connected to this NFT that cannot be faked because the values cannot be changed later on. And how do you know? Because you can see the code. So you can create a licensing mechanism just because there's storage. So you can attach information to IDs. You own this ID, you own this license, etc., etc., etc. So then I can prove, I can have composable licenses and other people can use them. Hold on, let's see. So it's a very interesting and exciting world, and we're trying to kind of find out what happens when we're trying to develop in this world. So I want to talk a little bit about what's different when you're developing. We already covered some of it. But the first thing, when you're starting to work in this world, is that you cannot change, mostly, you cannot change the code after you deploy it. Okay? This is terrible and beautiful at the same time. Because if you have a bug, you're screwed, right? So many projects create mechanisms of what to do and create upgradable contracts that allow you to create proxy patterns and stuff like that. So they can fix bugs. But there is this whole discussion in the industry whether upgradable contracts actually remove trust. Because if I'm using your smart contract, but I know that you can change its functionality tomorrow, then maybe I shouldn't trust it, because you have now an incentive or a centralization option to change the implementation of the smart contract. So do you choose this immutability and trust, and also being scared that someone's going to hack your smart contract if you made a small mistake? Or do you choose being upgradable? And this is a false choice, because there are actually things in the middle, okay? I'll give you some examples. You can have upgradable contracts, but the smart contract has to have a time lock built in, like a function that will actually not allow the upgrade, but will declare it that it's about to happen, so that users can choose whether to use the new upgraded version or not. And you can actually not upgrade immediately. So you can give your users a fair warning. And this fair warning is built into the smart contract. I'm just giving you some interesting ideas. I'm not saying this is the perfect way. Here's another example. You can have immutable smart contracts, but you can have new versions of them, and then the storage itself is just saved in a separate smart contract. So the logic, people can choose to use version 1 of the logic, version 2 of the logic, version 3, and this is actually very, very common, but they choose which version to use. But if you realize that you have a bad version somewhere, the only thing you can do, you can't just change the contract, but you can maybe have the storage saved in a different location. And then having maybe a mechanism that allows users to say, you should probably move to this new version because we have found a security bug in this version. So we're allowing the users the choice. And is that a good thing or not? I don't know what the right answer is. I'm just giving you an example of questions that you usually didn't have to ask. Because this is happening, we're giving actually a much bigger focus on security. I've never cared so much about security as I do now when I'm building smart contracts. And not only that, this caring about security when you're building something, because you cannot change it, so you're thinking about all things could go wrong and what happens and all the clauses. I'm taking that with me into code that is not smart contracts, which is what we've always wanted to do. We've always wanted developers to care more about security, right? Let developers write code that they cannot change, see what happens. I promise you. They're like, okay, hold on, let's hold off on that. It actually slows down development because you cannot do continuous delivery. That could be an issue as well. Storage is costly. You can't just use a million types of storage because every storage actually costs stuff, which means that when you add stuff and you change stuff, every transaction costs more for your users, so you have to start worrying about that. So there's a whole new industry about optimizing storage. There's this whole notion of this fat protocol and a thin application. Most of the value is in the smart contracts and very little is in the front end. And this is a very interesting way to think about it, because usually applications had most of the value, right, in both the back end and the front end. And now, because the back end is actually the thing that brings the most value, you have to differentiate on the front end, because anyone can technically build a UI that uses your smart contract if they really wanted to. Or they could take the code and create their own version of it, of the smart contract, and try to take away users. So in this world, how do you compete? It's an interesting question, and it creates a new set of incentives. It's all visible, which means that right now the idea of privacy is still a problem. So you'll need to encrypt information if you're going to put it on chain, if it's publicly verifiable information. But even though you can do that, you can also trace transactions of a specific account all over the blockchain, which means that some players will not want to participate because they do not want their transaction history to appear on chain, or you would have to learn how to create multiple different accounts for different use cases. So you might have one account for investing, another account for interacting with the different decentralized applications, etc. But it creates new interesting incentives. And we don't know what the right answer for everything is. Your wallet is your identity. You don't have to sign in with your email. You don't have to sign in with a password. You can sign in with a wallet, which means you just sign. You literally have the signature function in your wallet that uses your private key. So I don't need for you to log in. I don't actually need to identify you. As long as you have a wallet, your address is your identity. That's good and bad, right, for everything here. Centralization versus trust, we talked about that, and it's the slowest database in the world. So the only way that you should probably build on it is if you actually need some of the value we talked about. Otherwise, if you're going to put a bunch of points of centralization in your code anyway, you might as well not build it on the blockchain. That's why some blockchains actually are created by companies like IBM, etc., and they're private blockchains. As soon as you see the idea of a private blockchain, you should immediately just think that it's a private database because it's fully centralized, fully controlled by some entities. There's no way for you to actually trust it. You have to trust that they're not going to do anything bad with it. A private blockchain is just a really slow, publicly auditable database, but that could change at any time. So they could change the history of everything, etc. Centralization comes from the idea that we have all of these people working together in a way that they cannot control. What can you do tomorrow if you wanted to get involved in this? My recommendation, it's going to sound really weird, I want you to build your own little NFT project. Because NFT is the hello world of smart contracts. It kind of looks really, really simple, but it will force you to understand a lot of the concept we just talked about. And even for the simple stuff, you will actually have to start worrying about security. You will understand how things work. Try to do that. Build your own little NFT, see what it looks like. Create a simple website to allow people to mint the functions. When you can do that, you can actually start understanding a lot of the other stuff. You don't have to scam anybody, okay? But here's an example. You can make a free NFT just for the community here and allow people to mint it. And so then later on, if anyone who owns the NFT maybe has access to the next conference, like the speaker dinner or anything like that, you can do something like this, just as an example. So you can use it as an NFT for tickets. How would it be a ticket? Because somebody treats it as a ticket, right? That's the thing that turns it into a ticket. Anyway, that's where I want you to try. If you really want to try this stuff, look at Ethereum and specifically build on Polygon, which is a much faster and easier way to create smart contracts today. It's faster for users, has all the security. And if you have questions, feel free to ask me, send me an email. And enjoy your fika, everybody. Thank you very much.